Institute of Business and Computer Studies, Bhubaneswar, Odisha.
Good afternoon to all of you. Welcome to a new video from IBCS. In this video, we are going to discuss about the subject database management system. In my previous video from this subject, we discussed about relational model. In relational model, we discussed about relational algebra, in which we carried out few operations. Those operations were the select operation, the project operation, and the union operation. In this video, we are going to continue with relational model, but we will move on to the next part of relational model, which is normalization. In this particular video, we are going to discuss about the concept of normalization, why normalization is required, what is functional dependency, what is transitive dependency, and the different normal forms. There are in fact three normal forms that we are going to discuss. The first normal form, the second normal form, and the third normal form. But in this particular video, we are only going to discuss about the first normal form. In the next video, we will be discussing about the second normal form and the third normal form.
So let us start with the video. We'll start with the definition of normalization. Normalization is the process which allows the user to remove redundant data within the database. Redundant data means repeating data which are there within the database. This involves restructuring the table into meeting higher forms of normalization. Number 3. A properly normalized table should have the following characteristics. Number 1. Scalar value in each field. Scalar value generally means singular value in each field. So for example, let us say we have the attribute registration numbers for each student. Each of the fields should have only one registration number. But sometimes what happens, the attribute such as contact number, we may have more than one contact number. That should not happen. Number 2, absence of redundancy. Redundancy again means redundant data. Number 3, minimal use of null values. It may so happen there are few fields which are left blank. So that should not happen, and minimal loss of information. In this video, we are only going to discuss about the first normal form. In the next video, we'll discuss about the second and the third normal form. Normal form is the process which improves the database design by generating relations that are of higher normal form. The objective of normalization is to create relations where every dependent is on the key, the whole key, and nothing but the key. Here key means the primary key. As we have discussed earlier, for every relation there has to be a primary key. Next we are going to discuss about functional dependency. Now functional dependency is a very important concept so that we can understand the different normal forms. Now functional dependency, as we have taken an example here, let us say there are two attributes A and B, and for example let us say A is the primary key in this relation. So a primary key is generally used to uniquely identify a tuple, and which means that here the attribute A determines attribute B, or we can say that B is functionally dependent on attribute A. Let us take an example. For example, in a relation there are two attributes, one is employee number and another is email address. So obviously employee number is a primary key, because using the primary key we can identify one tuple. So that means no two employees can have the same employee number, and each of the person will have only one employee number. So here employee number is the primary key. So a primary key here, employee number, can be used to determine email address. So email address is functionally dependent on employee number. So let us take an example where in this table we have the employee number, email, the employee's first name and the employee's last name. And here obviously the primary key is the employee number. Now if this is the table, then we can assume the fact that following are the functional dependencies. We can have functional, that means we can say that employee email is dependent on employee number, employee first name is again dependent on employee number, and employee last name is again dependent on employee number. That means if we choose one employee number, we can determine its employee email. If we choose one particular employee number, we can get to the first name and the last name. So for example, let us say I choose the employee number 456. It will be able to determine Peter Smith. There are no two employees which will come up for 456 employee number. Functional dependency can be denoted in different ways. This is one way, this is the second way, and this is the third way. This is only the way to denote functional dependencies. Next is determinant. So the attribute which is on the left hand side, so here on the left hand side we have the employee number, so employee number is the determinant. So employee number is the determinant of employee email. Another important concept is transitive dependency. It may so happen, let us consider a relation which has got three attributes, attribute A, B and C. It may so happen A will determine B, or B is functionally dependent on A, and C is functionally dependent on B. So what will happen is we can say that C is functionally dependent on B and B is functionally dependent on A, which means that C is transitively dependent on A through B. This is the notation. For example, let us say the employee number will determine the department number, and department number will determine department name. So we can say that department name is transitively dependent on employee number through department number. The next concept is partial dependency. A partial dependency exists when an attribute B is functionally dependent on attribute A, and A is a component of a multi-candidate key. That means A is a part of a composite primary key. In this example, we can see that invoice number and line number in combination becomes the primary key. And we can see that the invoice date is determined by the invoice number. So we can say that the invoice number is the determinant of the invoice date, and invoice number is a part of the candidate key. A part of the candidate key means invoice number and line number together becomes the primary key. So for example, let us say the quantity is again partially dependent on line number. Let us take an example and see how it is done. In this example, there are four attributes: employee ID, course ID, employee name and course name. So obviously here the primary key is a combination of employee ID and course ID, and employee name here is only dependent on employee ID, not course ID. So employee name is partially dependent on the primary key, which is employee ID, which is a part of the primary key. And here course name is again dependent on course ID. So here we have only a partial dependency. Now we start with the first normal form. Now, what is the first normal form? We say a relation or a table is in the first normal form, or it is 1NF if all the values stored in that relation are single valued and atomic, and there are no repeating groups, and the relation must have one primary key. A table is considered to be in 1NF if all the field contains scalar values as opposed to the list of values, as we have discussed earlier. For example, in the attribute contact number, we can have more than one contact number, so the number of values are more than one, so it becomes multi-valued field. So multi-valued field is not allowed in the first normal form. When the first normal form places restriction on the structure of the relation and values must be simple. Let us consider this example, and as we can see, it says the following is not in the first normal form, and I'll tell you why. Employee number, we have got individual or scalar values in each of the tuple. There are three tuples and three attributes. Employee number, there are singular values. Employee phone, there are singular values, but in employee degree, we see that in tuple number 2 there are multi values, which is BA, BSc and PhD, and for tuple 3 the employee degree are BSc and MSc, so they are not singular values, so that is why this table is not in the first normal form. So in order to obtain the first normal form, we must, without loss of information, replace the above into two relation or two different tables. Now this is another way of representing the table, but still we have got repeating groups. We have got employee degree 1, employee degree 2, employee degree 3. So this is again another bad way of representing the table. Now let us see how, if a table is not in the first normal form, how it can be decomposed. So this is the procedure to decomposing the table into the first normal form. Number one, place all the items that appear in the repeating group in a new table. That means in our previous example, our repeating group is employee degree. So what we'll do, we'll put employee degree in one table and will designate a primary key. Now in this case, a primary key is obviously the employee number. So one table will have employee number and employee degree in one table, and in another table we would have employee number and the employee phone number. So this particular table will be divided into two tables. Number two, designate a primary key for each of the new table produced. Number three, duplicate in the new table the primary key of the table from which the repeating group was extracted, or vice versa. So as we can see, now the table is in the first normal form. The first table that we see, employee relation, which has got employee number and employee phone number. There are no repeating groups. And the other one is employee degree, where we have the employee number and the respective degree. Again, there are no repeating groups. Now if we join these two tables, we'll get our original table. Now let us take an example or an exercise for you to do. At this point of time, you can pause the video and you can carry out this exercise. Now obviously this particular table, which is a product relation, is not in the first normal form. There are three attributes and there are five tuples. Product ID is okay. Color, now in the first tuple we see red and green. That means this particular table or relation is not in the first normal form because we have got multiple value in a single field. So you can pause this video, carry out this exercise and try to put this into the first normal form. I hope you have come up with the solution. So as you can see, the previous table, this can be divided into two tables where we have the product ID and color in one table, and in the other table we will have the product ID and the price. So as we have followed the rules of decomposition, we will get these solution. Thank you for watching the video. Share your suggestions and queries in the comment section below. Like, share and subscribe the channel for more videos.